Hello everyone, welcome to my channel. Today I have picked three sum problem which is marked as medium on Leetcode, and it is in continuation with the problem we call two sum. So two sum has already been solved, and also when array is sorted and we have to solve the two sum, the problem is also solved. So those two problems it is recommended to solve before trying to solve the three sum problem. So let's quickly first understand the problem. It is given that we will be provided an input. Earlier we used to provide a target now for two sum problem, but we don't have a target right now. We just have to find three a triplet. I mean three numbers that would add up to zero simply add up to zero. And also, if you see, we are given the array and we have to find three numbers that would add up to zero. So, nums of 0, nums of 1, and nums of 2, which is minus 1, 0, and 1 is adding up to 0. So, order of the output, order of the triplet, that does not matter. But what matters is the solution must not contain duplicate triplets. So we don't have to, if suppose we have already found 1 0 minus 1 0 1, then we cannot add 0 1 minus 1 or 1 0 minus 1 in the opposite order. So this is a duplicate that we don't have to add in our solution. Also, what would we have to return an empty array if we don't have a possible triplet. And just in case if we have only 0, then it is simply the only it is going to be the unique solution. So these are the sorts of example we are given. Let's not waste our time and just quickly jump to the solution. First, I have done some previous work so that it does not waste our time. This is the force approach that I have written. So what do you think? How to proceed with the brute force approach? Let's see how it works. So for brute force, it is automatically the intuition goes to first. We will pick this problem and then we will try to find, like for one loop, we will pick and we will fix a number, and then we will try to find subsequent numbers for this one. So a pair we will try to find. So for this, let's suppose we have used first loop, then under second loop, we will fix one more number and then try to find. So when two numbers are fixed, it is simply equivalent to solving a problem which is like x plus, suppose, let me write it here. So it is simply equivalent to solving a problem which is like x plus y plus z equals to 0, which we have assumed that it is going to be. And then we are here in this brute force, we are first fixing x and y and then trying to find z. Okay. And then in every possible scenarios we are and then we are trying to find it for every possible scenario. So this would extend up to three loops that I have mentioned here in this algorithm which is written here. So let's first dry run this to avoid any kind of confusion. Suppose for this I we have for zeroth index we have let's when I what would happen the when this algorithm will run, it will run for I equals to 0, and for I equals to 0 we have minus 1 in the array. This is the array I have taken, and this is the corresponding index respectively that I have written above the array. So for zeroth index, we have minus 1. And for 0, first, it is at I plus 1. So what I have told that I have freeze this element and I will look for the other elements subsequently in the array. So it is j. So j would be 1. At first j would be 1. And for j1, we have 0 at first index. And then for I equals to 0, j equals to 1, then we will move up to k, which is equals to j plus 1. So for this j, we have k as 2, which is j plus 1. and nums of 2 is 1. So let's quickly add these three numbers. 1 plus 0 minus 1 plus 0 plus 1 is 0, right? So is this the target that we are looking for? Right now we are looking for 0. The three numbers should add up to 0. So yes, it is adding up to 0. So in the very first only we have found the first set of solution. So we will simply store it as a triplet here. And also one thing to notice, in the two-sum problem, we used to return the indexes of the array element that was adding up to the target. Here we are not required to return the index, but instead we are returning array elements only. This is a very important point that we have to always keep in mind. It is our, our optimized solution is going to be based on this particular scenario. So minus 1, 0 and 1 is our solution that we have already found. And also we don't have to return anything like 1 0 minus 1 0 1 minus 1. That is not going to work as a solution. So we have to always maintain. So in this brute force approach, the result is going to be a set, or whatever you have to maintain. Like we have to avoid any sort of result that is duplicate. So I'm simply going to write it so that it is result is going to be a set to avoid duplicates. You can follow and make a notes as well, so that you will remember the pointers I have mentioning here. I'm mentioning here. And now, so this we have found the solution. Now we are going to check for what we are going to check for 0. This both of these elements are going to be same, but we are just going to increment the k value of k. So value of for 1 and minus 1 and 0, we will look for 2. So is it adding up to 0? Minus 1 0 plus 2 is 1, which is not equals to 0, so it will not add up to the solution. Similarly, let me just follow this only. Similarly, for in array index 4, it is going to be minus 1. So does it add up to 0? No, clearly not. Minus 1 plus 0 plus minus 1 is minus 2, which is not equals to 0. So it will also not add up to the solution. And similarly, when we will come at the last index, it is going to be minus 5, which is obviously not equals to 0. The sum is not equals to 0. What is the sum? Minus 1 minus 5 is minus 6. Now, the first iteration for k is completed. Now it will return back to j, and for for I equals to minus 1, j would increment and it will take 0. Okay, and our I is going to be j plus 1, which is 3. Okay, sorry, k is going to be 3 and the value here is 2. So is it adding up to the solution? Minus 1 plus 2, which is 1. It is clearly not equals to 0. So we have to avoid the solution, and we will come at index 4, and then we will check at 4. We will see at 4 we have encountered minus 1. So minus 1 0 plus minus 1 is also minus 2, which is also not equals to 0. In this case as well, we could not find any solution. So the array, and also we have to, and then it will come till to minus 4. At minus 4 as well, minus 1 and minus 4 is also clearly not the solution we have found. So Here as well, it is going to be minus 4 minus 1 is minus 6. So it is clearly not equals to 0 again. So it will not add up to the solution. So we will add some those ones. Now our array will go to j index of j is going to increment, and it will come and it will check the value here is 2. So for 1, so for 0 is for I equals to 0, the value is minus 1. For j equals to 3, the nums of j is 2. Number at 0th index is 2. Sorry. Number as third index is 2. So nums of I is minus 1 at this point. Nums of j is 2 at this point, which I have already mentioned at the column header. So, and then uh, k, we have to compute k. So the k is going to be j plus 1, which is 4. And nums of 4 is minus 1. Let's quickly add it. Minus 1 plus 2 minus 1, which is 0, right? So we have found our another solution. And we are going to add it to the result. And you can clearly see that this is not a solution. This is not the solution which we have added earlier. It is different. Similarly, it will go up till end. It will check for k equals to 5, which is minus 4, which is not equals to 0. And then it will again move the j value of j is going to move for 4, and then it will check for minus 1, and then for k it is going to be fifth index and it is 4, so it is clearly not equals to 0. So similarly, it will go up till the end, like the value of I will come to the value of I will come to the value of j. The value of j will come to 5, and then it will the value of I also is going to go the up till the end index, and that's how the brute force approach works. Now, how do we now let's quickly move on to the optimal solution, which has the intuition, as if you remember, it is similar. I have written an equation x plus y plus z equals to 0, which we are trying to solve here, right? If you remember, during the childhood we were given this sort of equations as well. So what we used to do, we used to fix a number, right? We used to let the value of something, and then if we and then we used to write it like y plus z equals to minus x. And since we have to, if we let the value, it means that we have fixed the value, and it is some constant which we have fixed right now. And then we are trying hit and trial approaches to find the solution, to find the x. So suppose if we are letting the value of I as minus 4 here, so we suppose we are trying to find the value of minus 4, then what we would do, we would try to possibly find the combinations which is adding up to minus 4. Suppose if we will try to find minus 1, minus 3 in our array, something like that we can do to solve it. So this is the similar approach we will be using here to solve the problem. So the approach here is going to be, remember I told that here we don't have to return the indexes of the array element, but the array elements itself. It means that we can sort the array. So sorting the array is going to simplify the problem a lot. We don't have to maintain the indexes, original indexes like given in the array. So first approach is that sorting. So I have already sorted the array and written here. Now, since the array is sorted, we know that if we fix the element here, if we fix the element and then use the two pointer approach, listen to me carefully here because I'm trying to explain the kind of approach we are going to use. First, I have sorted the array, and then if the array is sorted and the one element is fixed, we know that it is easy to find, it is easy to do the hit and trial method, right? If like suppose we are trying picking two elements using two pointers, so it would be easy for us to compute like whether we are near the sum or we are farther the sum. So if our right now, if our current added element which we are iterating over is lesser, then we can move towards the right. Okay. So that the value we can adjust the value accordingly. So if the value we are looking for is smaller, then we can move to the right to make it higher end. Make it to the higher end. If the value is higher, so what we want to achieve, we can move towards the left side to achieve some smaller to achieve a smaller value. Let's quickly see how the algorithm is going to work. First is that I'm going to sort it. So I'll simply apply, I'm writing the algorithm, just algorithm, not the actual code. So I'll do the sorting and then we will fix. So for fixing, what we will do, we will simply write the code like this. And you can also use some like you can also handle the cases when the array length is less than 3. So we clearly know that solution does not exist, so we are simply going to return an empty value. And if the solution exists here, since we are trying to fix the element, we are trying to fix the element and we are trying to find rest of the two elements. We know that every time we are going to fix an element, we have to, since we have fixed it, we have to reach up till here only. It's unnecessary to reach till the last point. This is an optimized approach. So we can just go up till length minus 2 and then for fixing only, we are fix the value. Now what I just said, we have sorted the array. So we have now for the sorted array, and since we have fixed an element, for rest of the arrays, for these rest of the array, we can use two pointer. So one pointer at the and both of the pointers at the very end of the subarray that we are trying to process right now. So my left pointer is going to be just I plus 1 and right pointer is always going to be length minus 1. The length we are currently trying to process. Okay. And our criteria to break the, so now we have to do some operations over this array, right? Over this subarray, since we have fixed one element, suppose we have fixed these element here and we have come at this point, then our subarray is going to be this. So for this, our subarray is going, so the breaking criteria is going to be if my left is less than right, so it has to come out of this loop. And no, we have to run through the loop only till left is less than right. And the since the way I have mentioned earlier, what we are trying to find, we are trying to find x plus y plus z equals to 0, and we will be fixing the value of x. So right now I have fixed the value of x as nums of I, right? And then we will just try to find y plus z equals to minus x, whether we are able to find it or not. Okay. Or simply you can say we have, since we have fixed this value, it is easier to find the value of y plus z. Okay. Let it write this way only. Okay. Now, since we have these two elements here, we have these two elements, right? We have left and right. We can quickly compute the value. Suppose our sum. we have to achieve the value of sum as 0. Okay, so right now we know the value of x, which is nums of I, and we will simply we have value of x with us, nums of I. We will simply find the value of y and z. We will see whether y and z is adding up to minus x, that is, it is adding up to 0 or not. These three values are adding up to 0 or not. So this is the hit and trial method we will use. So that's nums of right. Okay, and we will simply find, if my sum is equals to 0, then we will store the value in our, sorry, we will store the result in our array, in our result. We will simply store the result as array, and we will push this as array of values, triplets. Okay, so, and further computation would also be needed, but I'll not complex my solution here first. I'll first dry run, and then I'll show you different scenarios that we will be handling here as well. So let's start with x when I equals to 0. Let me adjust the screen a bit. Yeah, so for since our array is sorted, so we are not going to process this array, but just this one. So for currently, when our I equals to 0, the value is going to be -4. Okay, and since this is freezed, the value of left is -1. Okay, sorry, I think there is some issue. Yeah, so the value of left is -1. I hope there is some screen freeze. Yeah, so you can clearly see for if my value of I is 0, nums of I is -4, and I am going to freeze this array. So here it will see for this one the value of this, the value here, we will try to compute the value left, and we will try to compute the value right. So for left, right now, if my I is 0, the value of left is going to be 1, which is I plus 1, and its array value is -1, and the value of right is going to be 5, and the value is 2, and sum is going to be -4 -1 2, which is -5 plus 2 is 3. So this is clearly not equals to 0. In this case, if you remember, the approach I used for two sum when the array was sorted, in that case, what I did, if my sum, the value, if the kind of, here I am trying to achieve 0, and the value clearly is coming as greater, right? -4 -1, sorry, it is -3. Okay, so here I'm trying to achieve 0, but it is -3. So clearly I have to increase the value. Since the array is sorted, in this case I will increase the left pointer, so that I can go up to some higher value, and so I will increase the left pointer. And let me also write the algorithm here. So else, if my sum is the sum that I am computing right now is less than 0, then simply increment the left pointer. And just in case the sum that I am trying to compute here is lesser, uh, sorry, sum is greater, then I will simply decrement our right pointer to get some lower value. So here these both elements is going to be, these left and right is going to be freezed only. nums of I is going to be the same, nums of right is going to be the same, just the value of left is going to change and it is going to be 2, and the number, array number at index 2 is also -1. In this same scenario, the sum is going to repeat, right? It is going to be -3, which is also not equals to 0. Okay. One more thing we have to notice here, which is clearly not the case at this point, but in the future, that you see the value if at I was at 1 was -1 and the value at 2 was also -1. So, and for value here -1, the left was -4 and the right was also -2. -4 and 2. Here for when I incremented my left, the here the value is same. In this case as well, the value of nums of I is -4 and the value at nums of is -2, and the sum is going to be equal. So in this particular scenario, you see the sum, the value I am getting after calculating is the same, -3 and -3. So suppose at this point, if the sum was adding up to 0, suppose I would have found out the solution, and I would have incremented my left value to find some other possible solution. But since the value is duplicated, it would have given me a duplicate solution. It would have given me a duplicate set of solutions, -4, -1 and 2. And here as well, -4, -1 and -2 only, because the sum is going to be the same. So this is a very big catch. We always avoid duplicates. At any point we find duplicates, we avoid it because it will add up to the same value, same set of solutions, which we don't want. We don't want the solution to be repeated. Okay, this thing please keep in mind. We will use this criteria and we will add it in a particular case. Okay, now let's come to solving and try to find the solution. For 0 minus 4, we are again going to increment the value of left only, because we are trying to move towards 0, which we haven't found yet. Okay, so at third index we have found 0, and here as well it is giving me -2, and which is clearly not equals to 0, right? Again we will move towards the right. We will move our left pointer towards the right, and we'll try to find here at this point my value of I is fixed, and we have processed this value. We couldn't find any solution, and we are processing just these two subarray, and we'll try to find the possible solution. For 0, for nums of I equals to -4, for nums of j equals to 2 at index 5th, we are trying to find the value of I. We are trying to, and we have reached till index 4th, and we are trying to find the solution 0. Have we achieved this? Let's add -4 plus 1 plus 2, which is -4 plus 3, and which is not equals to 0, which is -1. So in this loop, we clearly couldn't find any solution. Now we will return. We will simply see, the one loop is already completed. For I equals to 1, we have completed this loop for I equals to 0. Now we will go to I equals to 1. Okay, let's add some rows first. So we see now 0 for I equals to 1. Let's clearly take some. For I equals to 1, once my I is going to be 1, it is the value at array index 1 is -1. Array index 1 is -1, and the value at array index 1 is -1, and now our sub array is this. Okay, so the left is again the left value of left, so which is I plus 1 2. and at 2 we have minus 1 at index 2, and now the sub array is length minus 1, which is 5. So clearly some elements are going to get repeated. Yes. So let's compute minus 1, minus 2 and 2, which is adding up to 0 or not. Let's see. It is adding up to 0, right? So we have found one solution. We will quickly add this to sum is equals to 0. We have reached this case. We are quickly going to go and add this as a solution. 0, minus 1 and 2. Okay. Now, since we have found the solution, we are happy now, and what we will do, once we have found the solution, it is a possibility that inside the same condition for I equals to 2, so right now I equals to 1, in this particular, we are currently at this point and at this subarray. So in this particular subarray, for y I equals to minus 1, we can find some possible other solution as well. Like for value of left and right, we can do some more hit and trial and then come up to other solutions as well. Let's try. So for that we will at this point we have gotten the solution. So in this case, we will increment the value of left as well, and we will decrement the value of right as well, because one possible solution we have already found, right? So we don't want it to be duplicated. Now let's recompute the value of I and j. The value of left and right. Let's recompute it. So value of left is now coming out to be 3. At 3 we have 0. And what is going to be the value of going to the value of right? It is going to be 2. Okay. Sorry, 4. The value of right, which is decremented. Earlier it was 5, now it has turned to be 4, and the value at fourth index is 1. So let's quickly compute and see whether we have found some other solution or not. So clearly minus 1, 0 and 1 is adding up to some other solution. You see, minus 1, 0 and 1 is 0. So we have found other solution. Minus 1. So we will push this value as well. Minus 1, 0 and 1. Okay. Now clearly we have found two solutions here for I equals to 1, and now for I equals to 1, the value of I equals to 1 and array value nums of 1 is minus 1. We will increment the value of left. Here we have found the solution. We have pushed the result into we have pushed the values into the result, and we are going to increment the value of left. What is the value of left? It is going to be 4. 3 plus 1, 4, and the value here is 1, and 4 minus 1 is 3, and the value here is value at third index is 0, right? But is this the valid scenario? We have to is this the valid scenario? No, right? We can't, because you see these values we have already operated for I equals to minus 1, and for this value we have this case we have already operated, right? So also this is we have to only iterate through when left is less than right, so we don't have to consider this scenario. In this case our loop is going to come back to I equals to 2. Okay, I equals to at second index as well, the value is minus 1, you can see. So now for I equals to 2, this is going to be our subarray. For I equals to 2, this is going to be our subarray for I equals to 0, 1 and 2. We have reached a very particular case here. So just see how we are going to process it. We have clearly processed a value for I equals to minus 1 earlier. For the value nums of I minus 1, we have already processed it. Now we have again reached a point where we have given minus 1 for nums of I, and now we are trying to find we are trying to operate on the same subarray which we operated earlier, trying to find the values. So for I equals to 2, left is going to be I plus 3, I plus 1, so 2 plus 1 is 3, and the value at third index is 0, which we already know. In this table you can see, check the values earlier. And the value of right is going to be 5, which is 2. So minus 1, 0 and 2, is it adding up to a solution? No, right? It is giving me the value minus 1, which is 0. Now for nums of I, which is minus 1, and this is a very special case, you see how we are operating at it. And you see one, we have already, which is greater than 0. So in this case, we are not going to increment left, but we are going to decrement the value of right. So our left is going to be intact as 0, and the value of right is going to come up at 4. And the value at 4 is 1. Have we seen this earlier? Let's check. Since the value of I is minus 1, and at index 1 and 2, both of these are minus 1. Okay, so you see clearly in this table why we try to avoid duplicates. I told you, right? Everywhere we have to avoid duplicates. So here as well, you see this value at 4, for I equals to, sorry if you are having any issue with this table and some values, but I'm trying, you can, for your convenience, you can write the values somewhere else, so you can quickly go and cross check the values I am trying to read out here. You see the value at index 1 and index 2 both are minus 1. So what happens, why we try duplicates? This is a very crucial point. We avoid duplicates because it gives us the same set of values, because we are looking in the same subarray, minus 1 and minus 1. So we encountered 0, 0 and 1 and 1. So this is the same set of value, and this is going to create a duplicate set of results, which we clearly don't want. So whenever we encounter, so in the loop only, we first check, we add a check if the value of I is greater than 0, which is clearly a corner case. We have to first check whether the value of I is 0 or not, greater than 0 or not, and then the value of nums should not, the value of I at nums of I should not be equal to anything that we have already seen earlier. Since the array is sorted, it is obviously going to be the one index map. So we would simply not go ahead with the case. We would simply not consider this case now. Okay. So this is not going to be the part of our, this both is not going to be part of our algorithm. It is, I'm simply going to delete this. Is this I added, this I did just wanted to show you the repercussions of having the duplicate value. So this is not going to be part, we are not going to check for the I equals to 2. Okay. Yes. Now we will simply move up to the third index, which is our last index we are looking for, because since I will reach here, my left is going to be this and my right is going to be this. So we, to avoiding the duplicates and repetitive things, we are just iterating up to length of minus 2. So the value at index third is, we can look up to the table and it is 0, right? You can see here in the table. And my value at left is going to be 4, which is 1. And my value at right, which is going to be at fifth index, is 2. Is it giving me any solution? Clearly not, right? 3 is not at all equals to 0. And there's no scope we can decrement the value, decrement or increment the value of left and right, because we have reached up to the last index. I hope you have understood. The last thing that I have not written here is that it is, see, I have simply mentioned the value of left and right. We are going to increment and decrement. But what if there is some duplicate set of values like minus 1, minus 1, minus 1 up to n numbers. So to avoid such scenarios, because at any case I have shown how this repetitive value is going to give us repetitive solutions, so we simply avoid it. So in the particular cases like this, when the value is repetitive for more than 2 places, we simply check the nums of left is anywhere equals to nums of left plus 1. Till then this is happening, we are simply going to increment the value of left, and similarly we will do for the right as well. But for right, since we are decrementing, right, we are decrementing, we will do it as check for -1, and also we will decrement it. That's how we are going to solve it. I hope you have gotten some ideas regarding that. Let's quickly code this. Hmm. And we will, in the end, we will return this value. We will take the let result is going to be this. So first what we did, we sorted, right? We use sort. So we are going to sort the value. Nums. Also, let's discuss the time complexity first. In the brute force solution, the approach it is using n to the power 3. And here, if you see, first the sorting takes n log n maximum in every possible scenarios. You see, sorting takes n log n, and the two pointer approach here, it is taking n square, because we are using two loops for the one for first one is this, and the sub array we are using this, so it is going to be n square. And also n square, since n square dominates n log n. So the time complexity here is going to be n log n square. Okay. So I'm simply first I'll sort this. Hmm. I'll first let the result, and let me quickly paste and then do it like this, or I'll simply write the code for your convenience. Let's write along. Since the result is this, and let me also compute the value of length. Length is going to be nums of length. Okay. So if length is less than 3, we will simply return a value as result, which is empty array only. Now for let I equals to 0, I less than nums of simply length, okay, and then I plus plus plus. What I did was I avoided duplicates, right? If, and obviously it has to be for since I'm using I equals to 0, I have to consider the corner case. That's why I am checking for I greater than 0. Nums of I is equals to nums of I minus 1. I'll simply continue, and also I'll compute left and I'll compute right. Left equals to I plus 1, and right is always going to be length minus 1. Okay. And while my left is less than right, so my we are going to iterate up to, sorry, I have missed this point. My length should always, I'm iterating up till length minus 2 only. Okay, because here I am considering the value of considering the value till rest of the last two values through right and left only. So I'll, let's quickly compute the sum. This is the same x plus y plus z equals to 0 we are trying to find. So we have fixed the value of I, and now we are simply looking for nums x plus y plus z, the equation that I have written. Okay, right. And now we will check if sum equals to 0. If it is equals to 0, then we are going to push it into the result. Remember carefully, we will return a value in array form, not simply anything but array. So don't commit mistake and push the values of array only. The triplets I have inserted in the result. What we used to do, we used to, after I have found the array index target, I'll simply decrement and increment the values for the particular array so that we don't get any duplicates. And also, in case of multiple duplicates, we used to first check left always should be less than right. We have to strictly follow this criteria. And then nums of left, if my nums of left just in case is equals to nums of left plus 1, then simply increment my, sorry, it is left minus 1, because we are moving towards right one, so we will be checking the last pointer, what the value of, what is the, why we are checking left, nums of left and nums of left minus 1, because we are checking for the previous value. So just in case, remember this case, for particular left we have already computed the previous element, so it will give me the duplicates for the previous values. So we will be checking it for previous ones. For left we will be checking it for previous ones, and if this is the case, my previous element at left is nums left is equals to the current element at left, then we will simply move forward. And for now, my right value should also be greater than the left value. So we will check whether the element that we have already processed at uh, uh, at this point, is it same as the next element, like the element we have already come from. So it is going to be right minus minus. So let's not confuse here. Suppose we have processed at the very end and we are trying to move at the right index. So we already have moved here. So obviously we will be checking at this place. Since we will already have moved at, suppose we have already processed for 5, so we have reached to 4 here. Now at this point we will be checking at 4, we are checking for the next value that is same. Suppose it is same, then we will simply decrement and reach up to 3. So this is what we are trying to do here. And then we will check, and it is similar to the approach for the sorted array, that if my sum is less than 0, then we will simply increment my left pointer to achieve some higher sum. And if it is less than 0, it sum is already greater than 0, then we will try to reach some lesser value. And in the end, when all of these are done, we will simply try to return it. Mm, let's try to solve, see if it's working or not. Okay, it has given me some issue. Oh, I have done some issue. Okay, it is the pair, not minus. Now, what is the issue? Okay, I haven't pushed. So my solution is accepted. Let's try to submit this. Okay, it is submitted. Yes. So please try this solution, and I hope this is not difficult for you guys.